Okay, hello everybody. JP Kelly is my name, Principal Client Manager um, with Murphy Surveys. I'm based in our Cork office now. I'm here about 3 years. I've moved down family from here, so delighted to be in the real capital um, selling our wares. So I've applied for citizenship and I'm told it's in the post. So it's great to see bigger crowds coming to these events gradually over the years. We've supported CETA from the start, and we gradually see every year these regional events growing, so it's fantastic to see a full house. Um, I'm going to talk a little bit about technology integration and how you use various technologies and surveying techniques to implement BIM. So we crack on. Just a little bit about ourselves. Hopefully most of you know who we are. We have offices across UK and Ireland, head office in Kildare, we've a smaller office in Dublin. We employ about 25 now in Cork, offering a full range of services, and obviously UK as well. So we're up to about 200 staff now across Ireland and UK, so it's a real Irish success story from a small, humble family business to quite a large operation. We carry the usual high levels of insurance cover and ISO accreditation. We find more and more our technology is being asked for in high-tech industry, in pharmaceuticals, in the high-tech, the likes of the Intels, and then down in Cork we're delighted to be involved in the likes of Eli Lilly, Pfizer, MSD, all the big pharmaceuticals. So they're seeing the value in 3D technology also, and I'll touch a little bit on that as we go along. Some of our clients, again, a spread of various clients across Ireland and UK, and many of you guys, I noticed from the attendance list, we work in conjunction with your companies in Cork, and delighted to do so. So data capture, I suppose the gist of what I'm going to talk about today is you hear a lot about scan to BIM, laser scanning, point cloud, and yes, it's an exceptional way of capturing a lot of data for the 3D and BIM applications. But what we like to think we offer is a more rounded solution, not just utilising laser scanning, albeit a very important part of it, but we tie in our other capturing technologies. So you see on the bottom they're GPR, ground penetrating radar units. We use various types of scanners, so there's not just one type of scanner. There's handheld scanners, there's some scanners perform better in industrial, highly reflective stainless steel environments, and other scanners are better long distance. And the guys down the back, like and Topcon and all these companies that support CETA can tell you more about the technologies. We obviously refer to them, but what I would say is there's huge skill levels required and basic surveying techniques required to use the technology correctly, and I'll discuss that as we go through. It goes back to the fundamentals of geographical surveying and the old chain and tape, distance and angles, and precision measurement. A scanner is an amazing piece of equipment, but unless your basic survey control is installed correctly around the site and tied into national grid and tied into local grid systems or site grids, you lose potentially accuracy if it's not done correctly. So we'd say there's various tools for the job depending on what you need. So we combine all of these technologies to provide, let's call it an integrated delivery. So we can capture data using drone technology, UAVs, We can capture data on the surface using laser scanning and traditional survey methods, topographical surveys. As you heard Robert saying there, you can turn good 2D AutoCAD drawings into reasonably good models. So you don't always need to go out and capture that Rolls-Royce information from a scanner. You might already have reasonably good drawings, and we can produce reasonably good models from that. And then ground penetrating radar, again subsurface capture. We can capture that using our radars, and it's not just GPR, we use CAT and Jenny sondes, we lift all the manholes, we trace the routes, we clamp onto the cables. So it's not just running the GPR over the car park surface or the road surface, and it's a rounded capture of data, and we stand by it, and it's PAS 128 compliant, which is underground surveying standard that we would advise everyone to work to. So we can capture that data, aerial, ground and underground, and create an overall delivery to our clients in one model and in one central database in whatever format that you need. So laser scanning, you've probably heard a lot of people referring to it, and this is where I kind of hark back to old traditional surveying skills and getting qualified surveyors to do the scanning for you. This is a very simple video showing what does a laser scanner do. So it spins on its axis, and it's recording millions and millions of data points, point cloud as we all refer to. So it's spinning, it's set up on a known control point, and it's measuring distance, angle and height. So distance and angles from a known point. So it's the old basics of surveying, the X, Y, Z coordinate, except you've got millions of these points. It's the density of the points is colossal, and that is point cloud right there of that particular facility. And then we add the imagery, which the scanner also captures, and we create a more we colour the point cloud, so it creates a more realistic view. So that's what laser scanning does. It still goes back angles and distance. Where do you set the instrument up? Is it intervisible with the last scan position? Are you getting proper coverage of the site? Are you tying it into national grid? Are you tying it into existing buildings? Are you tying it in? So you must always go back to that accuracy question in terms of what you're surveying and modelling. So there's various ways you can feed into the model, as I've kind of covered that slide already. You can capture the data using various technologies, and that can all feed into the model or the final delivery to our clients. I'll talk about BIM to field. So perhaps you have already got a design model for your project, and you need to ensure that it gets built as per the model and in the right position. So we have capability of taking that model, clicking on the key points, and creating files, bringing the model into a fairly powerful tablet, connecting it to the instrument, and going to site and setting out those points live as you build. So in recent projects, for instance at Intel would be one that springs to mind in recent years, literally as the mechanical and electrical install teams were clamping their pipes on the rack, we were literally shooting the key junctions on that pipe and the key points of connection as they were just about to tighten up the clamps. So as soon as that thing is tightened up and in position and all the points of connection are within tolerance, whatever the specified tolerance is, you're never going to get it to 0, 1, 2 mil, but you get it to 5, 10 mil in an environment like that. Whatever the tolerance is, they knew immediately that they've built it as per design. So straight away, the drawings go off for sign off and approval. So from a commercial point of view, our client on that project was churning out his final drawings and his confederated model, and he was obviously cash flow was much improved. There was reduced delay on the project, reduced reworks, reduced cost overall, really, re-welding, recutting, etc. So they used 3D technology to install as they built, and that was just a total station with the coordinates loaded in from the model and shooting live on site on a daily basis. That was the kind of workflow we used. So you had a preliminary design where you're selecting the route through. This was a retrofit project in a very busy mechanical electrical factory, so a typical pharmaceutical factory where you're routing through a myriad of pipes and equipment. So we first of all verify the preliminary design, check, maybe set out just 25% of the points. Is it going to fit? Yeah, it looks good. There's a potential clash. Okay, goes back to the designers, final routing. We go and we set it out, and then, as I said, the live check and live setting out was happening with the plumbers and the electricians and the install teams working in conjunction with us. And immediately that evening, the as-built was sent off for approval. So gradually the client realised, after a number of weeks of checking our work, suddenly had confidence that this was going in as per design, and everybody was happy. The thing worked very well. BIM validation, we see a lot in the industry, a lot of upfront investment in modelling. So I'm just thinking of, there's a project, it was an existing factory unit, and IDA released this to a pharmaceutical company. So we were asked to come in and scan the structure, scan the existing factory. Went in, scanned it, gave the model to the designers, and that was it. Now, a substructure, steel structure, had to be designed within that unit. The substructure was installed, but they never got us back to scan that. So therefore, straight away, how do they know the substructure is in the right place? Was it, how could any massive steel structure be perfectly in the right position? There's always going to be problems on site with construction, and it was never scanned. They assumed it was as per the model, and then in come the guys installing fire hydrant lines and all the kind of ventilation systems, etc. And suddenly they started seeing clashes with the substructure. So there was a missing link in the process. When the substructure went in, they should have done a quick scan of it and updated the model. So they were working then with a reality model as opposed to a design model. So that can be done quickly, and you can see we can do comparisons. That's point cloud versus design, and again, Robert referred to it, his clash detection on the bridges. You can highlight these things in Navisworks and whatever softwares. It's possible to highlight clashes, and obviously that beam is in pretty good condition in terms of position, but we found many areas that weren't. It's also possible to do there's hybrid technology out there. The guys, there's a Leica have a system, an MS60, where perhaps you don't want to scan the entire room or the entire facility. It can be costly. The files can be large. You could be talking about half a terabyte or a terabyte of point cloud. You might not have the capability to handle that data. So you can potentially, if you're just interested in a small zone in the room, you can just scan that particular zone and survey everything else traditionally using the likes of an MS60, and you can produce a point cloud of the detailed zone, and then traditional survey points in line format, and that can be delivered in a CAD deliverable, in a block CAD deliverable. And so there's ways of approaching jobs. You know, it's all about what you particularly need. You might not need the rest of the room scanned. A recent example, we were asked by Skanska in the UK, it's a couple of years ago now. They were going out to the market talking to clients, and they wanted to show off that, you know, how an exemplar BIM model, how, you know, all the bells and whistles, LOD 500, and not just model, but actual information model, a building information model. And some of the guys have referred to that in their previous presentations. We're doing a lot of modelling in Ireland at the moment. We're not doing a whole lot of building information modelling. We're not pumping the metadata into the model. Clients are appointing designers and consultants to get the job built, and then the model or the point cloud tends to get put in a hard drive in the bottom of a drawer. And what we're trying to do is educate clients and owner-operators actually that, well, you've paid for this model in some shape or form, why not use it to operate your facility and to manage your facility? So Skanska said, right, show us what you can do. Here's our head office. Throw the kitchen sink at this and create a high detail model. So then we can go to our clients and our owner operators and show them what's possible. So we flew it, we did underground utility, we did scanning, we did topo survey outside, etc. And the next slide shows, for instance, the flexi ventilation system just above the suspended ceilings in the office. So the highlighted blue items, as you can see, all the information to do with those are on this drop down menu. So they're all the parameters, the metadata, the specification for the piping, when it was installed, who installed it, you know, and there's no limit to what you can put into it. It's like the old, I always refer to Microsoft Access. When that came out, everyone was all about this database system. It's useless unless it's only as good as what you put into it. And you can talk about information modeling and you can talk about how great it is, but you have to input that data. It costs money to input it, and as Robert touched on, if it's not in the bill of quantities, the client probably will shy away from doing it, and certainly no one's going to do it for free, but perhaps it's something they could embrace themselves in-house, and we're quite happy to partner with companies and have done so to implement BIM in their facility. So you can take the maintenance manuals, you can take basically anything to do with even a light switch, the make and model of a light switch, where do I buy a replacement, you know, you can go to that kind of detail if you want. They pretty much tagged everything in the model with some kind of metadata, but you can go beyond that again. Some sample projects, that's Dublin Airport, actually the baggage handling area. We were heavily involved with DAA, and they're installing some new X-ray equipment, so it's a retrofit project where obviously very tight space to work in, and how are we going to get these big X-ray machines in here without disrupting all of our passengers' baggage, you know, and how do we get this done. So the first step was to create a detailed model, and now they're busy working at a mechanical and electrical design to make that happen. This project is Diageo in Dublin, the Guinness warehouse. I can't remember which particular building it is. So that's pretty high level of detail. That's a lot of hours of modelling. It doesn't come cheap. You know, on average, you're probably looking at a day of scanning on site. Could be up to 2 or 3 days of modelling, depending on the detail that you require. So, as everyone has touched on, it doesn't come cheaply. It doesn't come easily. If you want it modelled, there is a lot of work involved, and I think a lot of clients are not aware of that. That's a pharmaceutical project. Again, the image on top, so the scanner, as you may or may not know, captures imagery as well. So we can give you a panel tour, photo tour of the area that we've scanned. So you can jump from one photo to the next and navigate yourself around the area that was surveyed. And then down below is the point cloud. So that's it's good to about 3 mil if it's done correctly. 3 mil accuracy type of, that's the kind of tolerances we work to. And it's a nice deliverable for a client. They can have meetings with other stakeholders, and they can navigate around the imagery and talk about how they're going to approach the project. I'll just pop out and show you just a couple of videos. Doesn't seem to, oh yeah. So again, the scanning of this is actually a job we did abroad in Belgium for an Irish client, but so we're willing to travel as well. But it was an interesting project, a high profile client, and we've just mocked up. Obviously, we've modelled everything for the client, but then we've just added a little bit of. I think this was done, I can't remember what software they used for this, just to give it a little bit of more of a realistic look. But you can see the level of detail that the drawing involved in all of that was drawn from point cloud, traced over, painstaking hours of modelling. Then, you know, every nozzle, every connection. Now, obviously, as you go along, you can create families of flanges and families of pipework and families of various pieces of equipment. So therefore, once you start investing, then once you have that particular tank modelled, you don't have to model it again. You can drag and drop. I didn't get to talk much about our drone work, but we're getting a lot more requests for drone footage, and we've 3 drones now. We've 2 fixed wing and a Topcon Falcon 8. That's a kind of a propeller system, and we can capture point cloud. A photogrammetry, not just imagery, so we can create reasonably accurate, up to 60 to 80 mil accurate in level from the air. So we recently flew the M28 route for Cork County Council in conjunction with RPS, and they're using that aerial imagery to similar to the work that Robert showed you in visualizing the route for public hearing, public consultation. It's better, much better imagery than what you're going to get on Bing and Google. It's more up to date, obviously. It's high definition imagery, so people can pick out their houses, and you can zoom in, zoom out. They can see what the road is going to look like in relation to their property, and then not only that, we flew Galway City recently for Galway County Council, I think it was. Now all of what you see there, we've modelled up from using the aerial data. So obviously we've got the image flattened to show you Ayr Square, but we've been able to create contextual models of the buildings around that, and that's all data that we captured using drone, or sorry, that was a fixed wing flight. We flew Galway City, I think, in a day, with the LiDAR, and we can then produce contextual models. So, you know, it opens up many opportunities for how county councils manage their cities, manage their towns, and they can start picturing what developments might look like in a streetscape, etc. I have a few other little now this is you seem to have a lot of Guinness stuff here today. Should have had Murphy's or Beamish. Sorry. So this is drone, all captured from the drone, and on hard detail again we're achieving 50 to 60 mil for roof inspections. That's an ortho rectify image, but it's also a point cloud, so it's a model. I'm not. So we've actually put the imagery onto the point cloud, if you get me. We've wrapped it. So geometrically, that's an accurate piece of a model, but you also get the added benefit of the realistic look to it. That's kind of where we're at now with drones. We're capturing detail again, 50 to 60 mil on hard detail, 70, 80 mil on soft detail for cut and fill projects. It's perfect for that. And this is a project we did in Holly Hill for Apple. I probably shouldn't have said it was Apple, but it's only shown the outside, so there's no secrets being given away here. Yeah, so what you see there, they have a Revit model of their entire campus. So every single asset, the car park, down to the lamp posts, the benches where they sit for their lunch, having their lunch, everything on their campus has been modelled. Now we also have UAV imagery. I don't have that with me here, but we also flew the campus, so they've got high definition imagery of the roofs of their buildings. So for mechanical and electrical upgrading of installing equipment on the roof, we can pull CAD drawings, 2D CAD plans off for them whenever they need, of the roof, for instance, and they use this, to manage their campus. This is just the first step, but they can start adding asset data to this, and every element that you see in that model there is individual. So the glazing, the walls, the lamp posts. So you can add attribute data to all of that. But I suppose the message I'm trying to get across is we can capture from the air and the ground, and we can stick the underground utility data all into the one deliverable, and that's what we feel is something no one else is doing. There's lots of people capturing the scans, there's a few people capturing it from the air, but to combine it all into one deliverable is what we like to call technology integration to get BIM implemented on a project. So I suppose if there's any questions, I don't think
Thanks very much, JP.
I've any more to add there. Thanks for your time.
Okay,